Okay, so we have a pre-calculus video here. This is notes from 4.7. This is following up our lesson yesterday with the law of sines. As I mentioned, we'll have law of sines. We have law of cosines. We brought up yesterday that, Pythagorean theorem, the SOHCAHTOA, those are great formulas. They work in a lot of cases, but again, they're limited because they only work for those right triangles. And so law of sines, as we saw yesterday, that works for any triangle. Law of cosines works for any triangle as well. It doesn't have to be a right triangle. So as we mentioned yesterday, law of sines, okay? With law of sines, we kind of mentioned it'll always work if you have angle, side, angle. Okay, so if you have angle, side, angle, using law of sines works great. Remember, you have to have that one pair when you're setting up your fractions. And if you have angle, side, angle, that will always get you there. Or remember, it doesn't work for congruency, but if you have two sides and a non-included angle, okay, law of sines also works. All right. Again, that can give you two cases, so it's not always the easiest, but you have to consider both cases. But law of sines works both cases for that. Okay. So today, law of cosines. Law of cosines works when you have side angle side. So you have two sides and the included angle. That's when this is going to work. Okay. This works a lot like, it looks a lot like, I should say, the Pythagorean theorem. It's going to look very similar to start with. So Pythagorean theorem would look like this. C squared is equal to A squared plus B squared. Okay. But again, that only works for a right triangle. Now they go through in the book a little bit and they kind of show where the rest of the formula comes from. So it's like an adjustment really because it's not a right triangle. So for that adjustment, I would just remember it's kind of the adjustment since it's not a right triangle. We have to subtract off 2 times A times B, which is so those two sides. And then that's being multiplied by the cosine of C. So it still involves those two sides and that included angle that's in between there. And what that'll do is find the side across from it. So if you'll notice, you have angle C, A and B are here. So it's the side across from it that you end up finding. Okay, so you can see it looks a lot like Pythagorean theorem, but I always just consider it has that little adjustment on there because it's not a right triangle. It has to have that adjustment. Okay, so let's look at an example here. And kind of like yesterday, we're going to go through and we're going to find side A and we're going to find the two missing angles. Okay, so let's find side A first. So you can see here we have side, angle, side. We have the two sides, the included angle. And we're just going to use this formula. So in this case, we're looking for A. So these letters can change. But in this case, A squared will equal these two. It doesn't matter which one is the A and the B. It's just going to be 14 squared plus 12 squared. So since you're adding them together, it doesn't matter which order. And then minus 2 times 14 times 12. Again, the order doesn't matter because you're multiplying them together. And then cosine of the angle, which in this case was 39.4 degrees. All right. So we can type all that in. I did that earlier. I got 80.36. 80.36. And then, of course, just like Pythagorean theorem, my last step is I need to take the square root of that. And I get like 8.9 something. I just rounded it to 9. Okay, so it's pretty close to 9. I just rounded it to 9. So that would be the length of that side. Okay, now if we want to find angles B and C, what we're going to do now is we're going to use law of sines. Okay, so now we have a side, an angle and a side across. Remember, that's when you can use law of sines. So in this case, the sine of 39.4 is to 9, as the sine of B, which we don't know B, angle B, is to 12. Okay. So again, just like yesterday, I'm going to cross multiply and solve. So that would be 9 sine B is equal to 12 sine 39.4. So again, all I have to do is divide by 9. And that tells me that the sine of B is equal to, again, I typed that in earlier. I got 0.8463. And again, you want to carry that out a few places. Don't round it to the nearest tenth because that can make a big difference. You want to go at least 3, maybe 4 decimal places when you do that. And then remember from there, what you're going to do is you're going to find angle B by doing the inverse sign of that ratio. And again, I did that earlier. Since they rounded theirs to the nearest tenth, I rounded mine to the nearest tenth of an angle as well. So I got 57.8 degrees. Okay. So now I have the missing side. I have a missing angle. I could use law of sines again to find angle C. But again, the easiest thing to do would be able to just to find angle C by doing law of, or rule of 180. So angle C would equal 180 minus the 39.4 minus the 57.8. And that would tell you that we get 82.8 degrees. So I found all 3 pieces. Again, just like we did yesterday, they gave us 3 things. We found the other 3 things using law of cosines to start, and then we use law of sines and then the rule of 180. So we actually use 3 different things to solve this out. Okay. So that's law of cosines. Let's take a look at another one here. This one's a little bit different. It doesn't ask us to find everything. It just asks us to find x. But you'll notice here we have the same idea. We have side angle, side. 2 sides in the included angle. That's when we can use this. So again, it's going to be x squared is equal to 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 65. Again, everything on that right side is what you need. All you have to do is type that all in your calculator. Again, we talked about it yesterday. Make sure you're in the correct setting on your calculator. We got to be in degrees. Make sure you're in that. We will be switching back and forth. When I did that, I got 55.19. Then remember, just like Pythagorean theorem, we got to take the square root of that. I got about 7.4. Okay, so 7.4, that would be the length of that side. Again, I could find the angles from there like I did up there. But again, sometimes they might just ask you to find one missing side. So there's an example using law of cosines. Okay. Let's take a look at another idea here. So for this, there's another use for the law of cosines, and that is we can use the law of cosines to find a missing angle. Okay. And what I mean by that is we don't have any angles. And that's very common in triangles. You might have all 3 sides, but you don't have any angles. So this is very powerful to do. All right. And what we're going to do is we're just going to solve this equation right here for angle C. So to do that, what I'm going to do first is subtract both of these to the other side. So I'm just going to do some algebra here. So C squared minus A squared minus B squared would equal negative 2 AB cosine C. Okay, so I just move those 2 things over. Then I want to divide by this. So I'm trying to get that cosine C by itself. So I'm going to divide by negative 2AB. So divide by negative 2AB. Okay. Now, that's going to leave me cosine C over here. It crosses off the negative, the 2, the A, and the B all at the same time. So it just leaves me cosine of angle C. All right. Over here, I'm going to clean this up a little bit. Since I have all these negatives here, what I'm going to do is I'm going to kind of reorder things a little bit and just make it A squared plus B squared minus C squared over 2AB. So what I did is I kind of got rid of the 3 negatives and just made that negative and just kind of clean that up a little bit. So A squared plus B squared minus C squared over 2AB. All right. And then again, the last thing you're going to do is I don't want to know the cosine of C. I want to know what C is. So to get C, we have to do cosine inverse of that fraction. A squared plus B squared minus C squared all over 2AB. And that is how you can find angle C. And so that's the same formula. We just solved it for angle C. But this is a formula when you have all 3 sides, side, 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 you can use this version of the law of cosines and you'll be able to find a missing angle. Okay, so looking at it from here, if we have this triangle right here, and let's say we want to find the smallest angle. So if you remember back to geometry, the smallest angle is across from the smallest side. So if they say find the smallest angle, I'm actually trying to find angle A right here. So when you're using this formula, remember the two sides on each side of it, that's your ABs. And then the one across from it, that's what goes here. So again, the letters can change, but just know that these are the two next to it. This is the one across from it. And then that'll give it to you. So in this case, to find angle A, I'm going to do cosine inverse of, again, it doesn't matter the order, but 12 squared plus 11 squared, and then the minus 8, it has to be the one across from the angle you're looking for. And then that's over 2 times 12 times 11. Again, I can type it all in just like that into my calculator. Okay. If I do that, and I did cosine inverse of all that right there, again, I rounded, I believe, to the nearest degree. I got 40 degrees. Okay. Law of cosines, you only get one answer that works. So we don't have to worry about the two cases like we did with the law of sines, which makes it a little bit easier. So once you do your inverse, you're done. Okay. And again, we could do that again. If I wanted to find another angle, I could do law of cosines again. And then once you have two angles, you could use the rule of 180. You can find all three angles of a triangle by using that law of cosines. Okay. So law of cosines, a little bit easier to use than the law of sines. Okay. But it's kind of that same idea. It can be used for any triangle. Either one of them is going to work. Law of sines, law of cosines, kind of depending on which sides they give you. In some cases, you can't do it. It's like right here, I can't do law of sines because remember, you have to have one pair. And if I try to set this up, I don't have an angle, so I couldn't do law of sines. Okay. So there's always one of them that you can use to get where you need to be going. All right. So the homework that is assigned to this, again, just a few more from the same section. I'm just going to do a couple of them here. We'll have a few more that we need to do. We're going to cover some more stuff from 4.7 yet. But just a couple problems practicing law of cosines. We did law of sines yesterday. And then we have some areas of triangles that we're going to look at as well. Okay. So that's 4.7. That's the law of cosines.